Hi everyone, this is a review of a graphene-based material for electrode in electrocardiogram sensing. The author of this paper are Dr. Amani Owda and Dr. Alex Casson from the University of Manchester. So I will start this paper by providing an overview and background of the area. Then after that, I will talk about the current state of art for the existing graphene-based material electrode. Then I will talk about the main bottlenecks of a graphene-based material electrode and the motivation for future direction and the perspective. This will be followed with a critical evaluation, and at the end I will provide an overall conclusion. So first of all, this paper provides a critical analysis and evaluation for three types of graphene-based material electrode that are suggested for ECG monitoring. Those electrodes, namely conductive dry electrodes, flexible printed in textility electrodes, and epidermal temporary tattoo electrodes. The electrocardiogram is a non-invasive technique used for monitoring the heart activity. This method is based on placing conductive gel-based silver chloride electrode, which is the gold standard electrode, on different locations of the human body to measure the electric potential of the heart. Although the silver chloride electrode provide good performance for monitoring the ECG signal, however, the lack of other factors such as flexibility, biodegradability, and the requirement for a conductive gel make them unsuitable for long-term use or for integration into clothing textility for next generation wearable. And here I would like to talk about the main issue or the main limitation of the gold standard silver chloride. The conventional gel-based electrodes are not suitable to be used for long-term ECG monitoring, and the reason for this is due to the allergic reaction and the skin irritation that might trigger as a result of adhesive wet gel. So the question here, why graphene-based material? Graphene-based material used because of the electrical properties, the physical and the chemical properties of the graphene, and the thermal properties of the graphene. And these can be summarized as follows: high electron mobility, physical and good physical and chemical properties, high thermal conductivity, and high electrical conductivities. All these factors make graphene-based material good to be used for measuring the ECG signal of the human body. Now, graphene-based material electrodes have a great interest in long-term non-invasive monitoring of ECG signal. In this paper, we have identified different types of graphene-based material electrodes. Those are conductive dry gel-free electrodes and the flexible printed in textiles electrode, and finally the graphene tattoo electrode. The following graph show examples of the current fabricated dry and wearable electrodes. So figure A presents the conventional silver chloride electrode and the new fabricated graphite-based pencil lead powder dry electrode and the pencil lead solid electrode. Figure number 2 shows the experimental setup for measuring the ECG signal using printed graphene in textiles. And figure C shows the ECG signal obtained from the wearable prototype graphene clad elastic smart garment. In terms of ECG measurement location, the ECG signal of the human heart were obtained from different locations of the body, and those are chest, wrists, ear, fingertips, neck, and ankle. In terms of ECG monitoring and testing condition, there are several different monitoring conditions have been investigated, and those are rest and sleeping during movement such as walking and running, where motion artifact will be present. In addition to this, under dry and wet skin condition, including underwater ECG measurement. Now, let me talk in details about each type of graphene-based material electrode. The first type is the conductive dry electrode. So, in terms of manufacturing a chemical fiber decomposition is a method proposed in the literature for producing conductive dry electrode, and this method was used to fabricate electrode by coating graphene on the top of conventional gold standard silver chloride electrode. For those electrodes, the signal-to-noise ratio improved by 7% compared with the conventional gold standard ones, and the skin-to-electrode contact impedance reduced by 78% compared with the gold standard one. The second type of graphene-based material electrode is the flexible printed in textiles electrode. In these electrodes, the printed graphene-based electrode have been demonstrated with a focus in textiles for integration into clothing using various types of textiles such as nylon and cotton. The results indicate that the new fabricated printable electrode having higher signal-to-electrode contact impedance compared with the conventional gold standard ones over the frequency band from 10 Hz to 1 kHz. For those electrodes, similar conductivity was maintained before and after washing, and the average signal-to-noise ratio was estimated to be around 22.3 dB. The third type is the epidermal temporary tattoo electrode. For those electrodes were found due to the growing interest of epidermal electronics. A graphene-based transparent epidermal temporary tattoo sensor was used for multiple purposes, and those purposes for measuring the ECG, the EEG, and the EMG. These studies reveal that graphene-based tattoo sensors are very flexible, easy to use, comfortable, and achieving high quality signals. Therefore, it can be used for sensing electrical and optical properties of the skin. Now, in terms of performance matrix, as it can be seen from the table here, for the three types of electrodes, there are factors demonstrated and there are factors not demonstrated. The factors demonstrated were found in the publication, where the factors that are not demonstrated is the factor that we need to focus on them in the future. So mainly the factors that are not demonstrated is that we need more tests about the flexibility of these electrodes, the polarization, the baseline wonder. We need to demonstrate the sustainability and the biocompatibility of those electrodes for long ECG monitoring. We need to test the variation in performance and the electrical property due to frequent use, and also we need to demonstrate the shape, the level, and the frequency of occurrence of motion artifact, in addition to more testing under interaction of those factors and beyond. This table summarizes all factors demonstrated for each type of those electrodes and the factors that are not demonstrated. I've mentioned some of them, but for further information you can read this table and you can refer to the references. In conclusion, the results show that the heart monitoring is possible with the graphene-based material electrode at the cost of generally reduce the signal-to-noise ratio compared to conventional gold standard silver chloride electrode. The potential for flexible electrode and electrode integrated into textility for clothing is greatly enhanced with the graphene-based material electrode. Further work is required on the graphene-based electrode for motion artifact, robustness, sensitivity, biocompatibility, polarization, longevity, and interaction between these factors is still required. So for further information, you can look at these references. And thank you very much for your attention, and you are welcome to ask any questions.